All right, so y'all should be seeing my pad sitting here. So we're going to start out in 2.1, and that deals with graphs of equations. All right, so are y'all seeing my pad?
Yes, sir.
Yes.
All right, so what we'll do, we'll draw a few straight lines, and then we're going to start, since this is college algebra, we're going to start dealing with curved lines and all these other functions, okay? So graphing in this class, the best method is by using points. Y'all, let me fix something. I got a lot of rebound on y'all. All right, so now let's get back to the screen. All righty, so y'all, let me see what y'all can do with something like this. If we wanted to graph y equals 3/2 x plus 1. Now, in foundations and other classes, they probably taught you 3 ways to graph: intercepts, slope intercept form, or using a table. In this class, since all of our lines aren't straight, the best method is by using a table. So on the table, I'm just going to set up an X and Y table. I'm going to pick X values, put it in for the X, and then see what I get from a Y value. So y'all should be familiar with this method for sure. So the trick is trying to figure out what kind of X values that I want to use. And y'all, I'll tell you on these, 0 is a good X value most of the time on these. So the question is, if we put a 0 in for the X, what would that give us for our Y value? And so y'all would just come down, put in your 0, and then we'd see what we get on that. So the reason I use 0, 0 times 3/2, that's going to give me 0 plus my 1. And then final, 0 plus 1 gives me 1. So when I put a 0 in for that X, my Y value I get is a 1. So now the trick is finding a second number to put in for the X so that I can get a Y value. And y'all, I'm going to tell you a trick on these. 95% of the time, when I got a fraction being multiplied by my X, I pick my second X to be the same as that denominator. And then I'm going to write this out and show you why I did that. So say I got Y equals 3/2. I'm going to put a 2 in and then add 1. So y'all, the reason I use that 2, because now when you multiply a fraction times a number, if this number matches that denominator, 2 divided by 2 basically turns that into a 1. And notice the fraction's gone. All I have now is 3 times 1, which is 3, plus my 1. And then 3 plus 1 gives us 4. So when my X is 2, my Y value is a 4. So y'all with me on that?
Yes.
All righty, here we go. So so my numbers are small, so I'm just going to go out about 5. All right, y'all. So remember, 0, 1 up here in my table is the same as this point, 0, 1. And then 2, 4 is the same as 0.24. X's can go left or right. Y values go up or down. So I always start at my origin here. And since my first X value was 0, I stayed there. And then I look at the Y value, which was 1. So I'm starting at 0. I go up 1 for the Y. And I put my first point. But then I'm going to do the same thing with the second point, 2, 4. So starting at the origin again, I would go right 2 this time. And then from there, I would go up 4 for the Y value, which puts me about right here. Now, since this is the graph of a line, all I needed was 2 points. So once I got my 2 points, I would draw my line right through there. Now, what's nice is we got calculators, and I can put this equation right into that calculator. It would give me these points and everything else. So y'all, what I'm going to do is share the calculator with us now. I don't remember if seems like foundations, they didn't let y'all use calculators, but I'm not sure. All right, y'all, to graph this on the calculator, you would hit this Y equals button. So these top buttons up here, these top 5 deal with the graphing. So you'd hit that Y equals, and then you'll see Y1 equals whatever. That's where I would put in my equation, my 3/2 X plus 1. Now, here's a little trick. If you want it to look like a fraction like this 3/2 is, if you would hit the alpha button, which is green, and then the Y equals button, number 1 where it says N divided by D, that is calculator lingo for a fraction. So if you hit enter on that, it brings up the fraction, and you can put in your 3 on top, and then arrow down and put in your 2. Now I'm going to arrow right. To get my X, there's 2 ways. You can hit the green button, and then down here where it says STO, since there's a green X above it, it would put an X. But y'all, the easiest way is up here. You see the green alpha button? If you look 1 button to the right, it's got an XT, theta and an N on it. If you hit that button, it'll put the X right there for you. And you don't have to use the alpha button to get to it, okay? All right, then I'm going to put in my plus 1. So y'all, we got our equation in there. So to show you the table of the X and Y values, I'm going to hit second graph. You see above this graph button on the far right top, it says table in blue. So what that means is to get the table, you hit the blue button second, and then the graph, it's going to pull up that table. So let me see, I'm going to arrow down because some of the values that I was using down here. So if you look up here, here's the X value 0. They got a 1, which is what we got. And see, the reason I didn't pick 1 was because I didn't want to have to graph a fraction like that 5/2. But when I came down and we used 2 for our second X value, we got a 4, which is what that graph is showing. So you can use this table to check yourself on those points. Now, if you want to look at that graph, you hit the graph button, and there's our graph. Now, let me fix mine back so I can get a 10 by 10. I'm going to hit zoom and standard number 6. Anytime you hit zoom standard, it'll put it back as a 10 by 10 graph, okay? All right, question on that.
So basically, for the points, it's gonna stop at graphs, right?
Say
Where-
again?
it's gonna stop at graph where you got us where you showing us where you typing everything in it. So basically, stop at the graph button.
Right.
Where the points will be at.
Yeah, it'll be second graph right here, and there's your points.
Okay.
So if you're weak at solving them, y'all, or finding them X and Y values, graph it, get your values, and then you go to MATLAB and put it into that graph, okay?
Okay.
All right, so the way they mess y'all up on these, or they try to trick you, is by having you graph something like this, 6y plus 3x equals 9. So they know on the ones that are solved for y, you can just throw them in the calculator and get your answers. So sometimes they'll throw you a curveball and give you one that's not solved yet. So what I would do to this problem is actually solve it for the y. I want this y all by itself on the left side. So when we solve an equation for y, we first need to get this 6y by itself. So that means we need to do something with the 3x. So we really need this 3x to move to the other side. And so to move stuff from side to side, you're going to either add or subtract. And it's usually opposite of whatever they got in front of them. So since this 3x is positive here, we're going to subtract 3x from both sides. Because what happens to the left side of my equals? I got my 6y. But y'all notice you got a 3x and a negative 3x now. They cancel out. So all that's going to be left on the left side is the 6y. So as far as my right side goes, I got 9 minus 3x. So the thing you got to remember on that, those are not like terms. So I'm not going to get a 6x out of that or a 6 or anything like that. These are not like terms. So I'm just going to bring it down as a 9 minus 3x. Okay. So that's what you got to watch out for in here is whether they're like terms or not. So now, y'all, I got 6y equals 9 minus 3x. We want to turn the 6y into just 1y. So, and basically, I'm going to do the opposite of what they got shown. So this 6 is being multiplied by the y. So what we want to do is come in and divide by the 6. And we got to divide everything by the 6. Because remember, multiplication and division is distributive, and you got to do it to every single term, okay? But y'all watch this. 6y divided by 6 leaves me 1y. All right, so let's see. 9 divided by 6. We can't divide that, but we can definitely reduce it. So y'all, what will a 9 divided by 6 reduce to? So how about this? Is there a number that 9 and 6 will both divide by?
3.
So it will divide
3.
by, so 3. So we're going to divide both top and bottom by the 3. So 9 divided by 3 gives me a 3 on top. And then the 6 divided by 3 gives me a 2 on the bottom. All right, then that's going to be minus. Well, the same thing here. Both of these got what? 3's in them. So 3 divided by 3 gives me a 1. 6 divided by 3 gives me a 2. and then bring down my X. Y'all, at this point, we can run to the calculator and punch this in for our Y1. So let me take us over there. And then that'll give us some points we could use to graph it. And what I'm going to do, let me get 2 points from the calculator. And I'm actually going to show y'all how to graph this in the MATLAB, okay? So let's go to our calculator. All right, I'm going to clear this. Let me go back to my Y equals, and I'm going to clear that out. So notice this time I had a 3/2. So I'm going to hit alpha Y equals to put in my first fraction. So I had a 3 on top and a 2 on the bottom. And then we're arrow right. Then I had minus. And then we'll hit alpha Y equals again to get another fraction. And this one was a 1 on top, 2 on the bottom. Then I'm going to arrow right and put my X. So I have my 3/2 minus 1/2 X. So I'm going to go to my table first, and I'm going to try to find me 2 points that look easy enough to graph. So I'm going to hit second graph. So y'all, if you want to avoid fractions, my first point would probably be 1, 1. So I'm going to put a 1, 1 down. And it looks like every other point's going to be a fraction. So then I'm going to go down and do the second point I'm going to pick would be 3, 0. All right, y'all. So let me take us to MATLAB and show you actually how to graph these. All right, y'all, are y'all seeing my question number? Let me bring it to number 2. So are y'all seeing my question 2 on the screen? All right, so the graph in here on the left side, you see where it says click to enlarge graph. I'm going to click that. And it brings up the little graphing box. So up here on the top right, the arrow is just a pointer. The second one you see on the top right says line tool, which is what I'll use on this graph. The V is the absolute value tool when we use absolute value.
I'm not seeing anything.
Okay, let me pull up my screen here.
I just see the MATLAB.
Okay, let me
It's
try
on
this.
like the assignment page.
All right, how about this now?
Okay.
Are y'all seeing it?
Yes.
Okay. So on the top right, you see an arrow, that's just a pointer tool. The one after it is a line tool, and you notice it's got 2 dots. That means we need 2 points. The next one looks like a V. It's got 2 dots on it, which means I need 2 points. And when I get to that one, I'll explain about what points you got to pick on it. Then on the second row, you see a vertical parabola tool. We'll use that on the X squared graphs. And these other 2 we won't be using in this section. So the main ones will be the line tool, absolute value, and then that parabola tool. So what I would do on this, since I'm graphing a straight line, I'm going to graph this line tool and click it. And if you notice in the top part of that yellow banner on top, if you notice on the right side of it, as I move my points, it changes those numbers. So my first point was 1, 1. So I'm going to go right 1, up 1, and then click. So my first point was 1, 1. Then my second point was 3, 0. So starting here, I'm gonna go right 3. Since my y value is 0, I stay there and click it. And y'all, that's all you got to do to graph on here. And then you just click save and then check your answer. Now I'm not going to check my answer because it'd be wrong because MathLab didn't use the same problem I use. But yeah, that's all you want to do to graph on here, okay? So questions on that?
Nope.
And y'all, those videos I'm gonna send out, well, the videos I got in MathLab, Blackboard, they show you, there's one in there about graphing in MathLab. It'll show you all the different graphs and what to do to them, okay? All right, so something y'all probably didn't mess with in foundations was the x squared graphs. So let me tell you, x squared graphs make what we call a parabola, which is U-shaped, or if this was like a negative in front of the x squared, it flips it over to an upside down parabola, okay? Now, we can still graph these on the calculator, but I wanted to do one by hand just to show you what numbers you would pick on this. And remember, it only needs 2 points to graph this, okay? So in this section, we only need 2 points. Now later on in life, our parabolas will take 3 points. But in here, we only need 2. The 2 points I would always pick would be 0 and 1. All right, y'all, so let's put a 0 in, see what we get. All right, so 0 squared is what? 0 times 0, which is going to give us a 0. So when x is 0, y is 0. Then I'm going to put in my 1. All right, so 1 squared, basically what? 1 times 1? Well, 1 times 1 is 1. There you go. All right, y'all, let me let 1 in real quick. All righty, so got my 2 points. So let me show y'all how I would graph this by hand first. So y'all, I'll just go out about 5 again. For me, the worst part about graphing is drawing all the graphs. All right, so 0, 0, that's going to be the origin. Right here in the center is the 0 point for both x and y. And then I got 1, 1, which will be right 1, up 1. Now, MathLab automatically knows that these graphs are what we call symmetric. So it's going to come up and draw one side, and it will automatically draw the other side for us. Okay, so like I said, we only needed the 2 points in here. So let's go play with that on the MathLab. All right, so that was number 3 here, it should be. All right, so theirs is similar, but I'm going to do mine, which was x squared. So you would click on this enlarge graph. This is the Oh, okay, so they did go with a 3-point in here, so let me go back and get us another point. All right, y'all, so the third value I would use is a -1. Always use 0, 1, and -1 in this section, and you'll have no issues, okay? So y'all, here's the question. What is a -1 squared equal?
I just that's my ID. It's suspended. Yeah.
Oh, I couldn't hear what y'all
-1.
said.
Okay. I gotta pay a fine.
-1.
I didn't even notice it said ID.
Oh, I'm gonna have to mute something. I'm hearing someone else.
It's got to do with pictures.
Mhm.
And I'll let you take your car and pop it on with oil. So
Y'all hang on just a second.
send it in the Hummer.
I think that's Lanisha.
I'll put some pictures that you want through.
All right, so if y'all got an answer, just hit that mute button, unmute yourself, and then tell me, okay? So here's the thing, y'all. -1 squared is not -1. What's a negative times a negative equal?
Positive.
A positive.
Positive. So especially if you do negative numbers on calculator for exponents, put those negative numbers in parentheses. So then you got -1 times -1 is actually going to make that a +1. Over here, if you'll notice, since parabolas are symmetric, whatever value you get for a +1, you're going to get for a -1. Same thing if I'd have used 2 and -2. Both of them would have gave me the same answer, okay? All right, so let's do this on the calculator. I'm gonna go y equals, I'm gonna clear this. So I'm gonna hit my x and then square it. So hit the X button. On the left side over here, about the 5th button down on the left side, you said x squared. If you hit that, that automatically makes the exponent of a 2. So there's my x squared. I'm going to show you the table. I'm going to hit second graph. And I'm going to go up and show you a few of these negative numbers here. So notice I got my 0, 0 in the middle. At -1, I got a +1. At +1, I got a 1 for the y. Y'all, since this graph is squared, any number you square will become a positive due to the like signs. So that means all my y values have to be positive on this graph. And notice the symmetry. At 0, you got 0. At -1 and 1, you got 1 for them y's. -2 and 2 gave us 4. -3 and 3 gave us 9, and so on, okay? All right, so there's my points. So let's graph it in MATLAB. All right, y'all, so I guess we would be using the 3-point quadratic tool. So click that. And then you start putting your points. I got 0, 0, which will be right in the center. I had 1, 1, so go right 1 and up 1. And then I had -1, 1, so go left to -1 and up 1. Once you put your 3 points, you got your U shape drawn, save that and be done with it, okay? All right, y'all got questions on that yet?
No.
All righty, so let me go through a few more of these. All right, now this one, I would probably definitely do on the calculator. Y equals -1 over X. And y'all, let me show you MathLab on this. So that'd be number, let's see, number 5. So -1 over X. It only wants us to pick one of those 4 pictures. So on this one, I would just probably go to my calculator, graph this, and be done with it. So let me bring up my calculator. I'm gonna clear this screen real quick. I'm gonna go to Y equal and clear that. So remember, it was negative. Now here's the thing. When you're doing negative numbers, down here on the very bottom, you see that negative in parentheses? That's the negative you got to hit. Okay. If you use the subtraction negative, it'll give you an error message. So you got to use the negative that's in the parentheses. And then I'm going to hit alpha y equals to get my fraction. Hit enter. I got a 1 on top. And then my arrow down and put my X. Now, y'all, since we only had to find one of the 4 pictures, all I'm going to do is hit graph and see what this picture looks like. So notice it sort of goes uphill on the left and starts shooting up that y-axis. And on the right side, it comes from the bottom of the y-axis and starts hugging that x-axis. So remember that picture and let's see what we want, A, B, C, or D. All right, y'all, A, B, C, or D.
See?
See, there you go.
Oh. It was, yeah.
I think, yeah, see, remember it went uphill on the left side. So you just pick and then move on, okay?
Let's see. Sorry.
All right, y'all, watch this one. I got some lines, and then I got an X plus 5 inside these lines. So the question would be, what's the lines represent?
I could be wrong, but is it absolute value?
Oh, it's definitely absolute value. Good job. So these are going to make a V-shaped graph. And they got 2 points on it. But y'all, this one's really, really, really picky. The point where the V is, that has to be the first point we plot. Now, I'll show you on the calculator, it's pretty easy. But this first point we plot has to have a Y value of 0. So here's the question. What X value could I use that would give me a Y value of 0? So you're just thinking, what makes it equal 0 inside them bars?
Zero?
Well, remember, 0 plus 5 will give me 5.
Oh, yeah. -5?
-5, that's what I want. So whatever you have inside the bar, go with the opposite to get your first X. Because -5 plus 5 is 0. Absolute value of 0 is 0. And y'all, after that, you can pick any other point you want. You could use a 0 for the X. If you put a 0 in here, you got 0 plus 5. What's the absolute value of 5? Absolute value of 5 is 5. So are all of y'all familiar with absolute value?
Not really.
So let me
I remember it from high school, but it's been a
Sort of.
while.
well, let me review
Yeah, it's been
you
a
a little
minute.
bit. Let me review you on this absolute value real quick. So the absolute value of 0 is 0. Absolute value of 1 is 1. What's the absolute value of -1?
-1, ain't it?
1.
Oh, there you go. It is definitely 1.
Oh, okay.
So let me show you where absolute value comes from. Absolute value don't care about your sign in here. What absolute value is looking at, if I was on a number line right here, and let me throw a few negatives over here. Absolute value don't care what direction you are. Absolute value only wants to know how far from 0 are you. So notice, absolute value 1 was 1 because that was just 1 unit from 0. Now, -1 is just 1 unit from 0. So that's why it still equals 1. Just like absolute value of 3, that's 3 units from 0. Look at -3. It's also 3 units from 0. So absolute value don't care about what sign you are. Absolute value only wants to know how far are you from that 0. We don't care whether you're in the positive direction or the negative direction. We just want to know how far you are, okay? So absolute value of -7.
7.
Yeah, let me see. My chat might be trying to answer. All righty. So yeah, that is definitely a 7. So y'all, I'm gonna go graph this real quick in MathLab. Well, let me show you how to do this on the calculator real quick. So I'm gonna go to y equals and clear this off. So here's the thing. You don't have a button on front saying absolute value or anything. So to get absolute value on the calculator, I hit this math button. And then I'm going to arrow right 1 until I hit number. So once you hit the number column, the very first thing you see is an ABS. Guess what? That stands for absolute value. So you would just hit enter. And then I had what, an X plus 5. So inside these bars, I would hit an X plus 5. Then I'm just going to arrow out. So y'all look, it's going to do the absolute value of X plus 5. So let's look at that graph by hitting graph. So notice it's a V-shaped graph that went left. And guess what this X value is right here? That's that one y'all told me a while ago, that -5. That's the X that made it equal 0. Because anything on this X-axis has a Y value of 0, okay? So that's always where the point's going to be in this section. So let's play with this on MathLab. All right, so this should be number 6. Oh my God, it gave me the same problem actually. So I'm going to click to enlarge my graph. So you want to come up here to
Sure,
this. Are y'all seeing? Are y'all seeing the graph?
Yes, sir.
Yes.
All right, so up here at the top right is the absolute value tool. I'm going to hit it. Now, y'all, let me show you what happens if you don't put them in the right order. So if I went 0, 5 first, and then -5, 0, see what it did? It made my graph upside down. And we don't want an upside down graph, so we're going to cancel that and then click on this again. So remember, the first point you got to put is that V point, which had the Y value of 0. So that means -5, 0 would have to be your first point. And then we would do the 0 up 5. Now it looks like what I had on my calculator. So y'all, that's why it's very important that the y value of 0 has to be the first one you plot on here, okay? So you just say that and then be done with it. And then y'all remember, I've got my videos in MathLab that have all those graphs on it, 1 through 8 for you to play with, okay? So 2.1 deals with getting you used to the graphs. All right, y'all, so let me give y'all about a 5-10 minute break, and then we'll knock out 2.2, okay? So I'm going to pause our recording so that we can take a little breathy break. All right, so we're going to look at section 2 now, and it deals with functions and graphs. So let me get us on that screen. All right, y'all, so functions and graphs. So the first thing we'll figure out is how to determine whether a correspondence is a function. So our correspondence, they're just going to give us a little table. It'll have the domain on one side and the range. So if a correspondence is a function, that means every x value can have one and only one y value. That means the x values can't have a choice between the y values. If I put in an x value, I can only get one y value out of it, just like your paychecks. If you work a certain amount of hours, if you put that amount of hours in, you want to make sure there's only one output or y value that you get for your pay, okay? So remember, x's cannot have a choice. Okay, now more than one x can share the same y value. So remember that more than one x can share a y value. Okay, but each of those x's can only have one y value. Okay, so let me show you some of these examples they're going to do with you in this. So for these examples, we're going to determine if the correspondence is a function. So y'all, I'm going to put my domain on the left side here. So my domain for this problem will be 23, 12, and 5. Then my range values, and y'all remember the domain is your x's, and the range will be your y values, okay? So my range values are going to be 20 and 2. So the 23 points to the 20. The 12 points to the 2. And then this 5 points to the 20. So y'all, I ask you, is this correspondence a function? Yes or no?
Yes.
Yes, it definitely is a function because 23, that x value only has one y value 20. The x value of 12 only has one y value of 2. And then remember, this x value of 5 only has one y value of 20. Now remember up here, we did say more than one x can share a y value. Well, 23 and 5 both shared 20. But 23 and 5 only had one choice for their y values. So good job. This is definitely a yes. So let me try that again. Let's do another domain and range. All righty, let's see. On this one, I'm going to do -5, 2, and 7. Over here, I'm going to have a 3. So -5 points at 3, 2 points at 3, 7 points at 3. Is that one a function?
No,
All right, so what's making you say no?
honestly, I kind of just guessing.
So let me ask you this. How many y values does -5 point to?
3.
Well, yeah, but it's only one value, right?
Yes.
And then 2 only points to the 3, which is only one value for the 2. And then
Yes.
the 7 only points to the 3. So you're focusing on these x values over here. And you're trying to see how many y values they're pointing to. But since all three of these only point to one y value, this is actually going to be, yes, a function.
Okay.
All right, so let me show y'all one more.
Right.
Maybe this one will get y'all.
Can you turn that back around right quick so I can write something down?
Uh-huh.
Okay, thank you.
All righty. So what if I had 1, 5, 7, and an 8 for my domain? My range, I'm going to do, say, -3, 4, 7, 6, and 9. So the 1's going to go to the -3. 5's going to go to the 4. 5 is also going to go to the 7. And then the 7 will go to the 6. And the 8 will go to the 9. So the question here, is that a function?
No.
No, and that's because of the
5.
5. So notice the 1, 5 is pointing to 2 different y values. So that's violating our rules for a function, and that'll be a no. Okay, so remember, you're focusing on the x's. How many y values does my x point to? If those x's all pointing to one y value, it's a yes. But if any of these x's point to more than one y value, then it is a no. Okay. All right, y'all. So then we get into what we call evaluating a function. So the first thing we got to do is figure out this f of x lingo. What's it mean? So f of x notation, lets me know that I'm dealing with a function. The x, this tells us the variable. So when you see f of x, they're just letting you know, hey, I got a function f and the variable is going to be the x's. Sometimes when you get into the sciences, they might do something like f of t, letting you know t is the variable for temperature and stuff like that. But it tells us the variable. Now here's the thing. If I put a number where the x is, if a number is given for the x, or how about the variable, any variable? If a number is given for the variable here, then we replace the variable with that number in the expression. So y'all, let me show you what I mean. What if I had something like this? F of x equals 5x plus 9. The right side is the expression. The left side is only symbolism, letting me know that I got a function and that the variable is the x. Okay, the left side does not get worked at all. All we do is plug in for the x's and see what we get for this expression, okay? So if I gave you something like find f of 2. So I'm telling you, I got a function and I want us to put a 2 in for the variable. So we would do this. F of 2 would equal 5. In place of the x, we would put our 2 and then come down with our plus 9. So f of 2 looks like f of x, except in place of the x, we're putting a 2. And then this all goes back to order of operations. I got to multiply before I add. So 5 times 2 would give us 10 plus our 9. And then 10 plus 9 would give us 19, which means f of 2 equals 19. So just bringing back memories, hopefully.
Yes.
Yeah, that's
Mhm.
all this f of x is. It's just lets me know I got a function like I did right here. And then if I put a number there, it tells me what to put in for those x's. It's sort of like shorthand for math. So we're going to do some of these real quick and see how y'all do on them, okay? So y'all ready for the flip? All right.
Yes.
So they're going to give us a function k of x equals x plus 11. They want me to find k of 0, k of a negative 17, k of a negative 9, k of 20, and then k of a b plus 2.
You feel like
And y'all look at that. That's 1, 2, 3, 4. So basically, it's almost like 5 problems in one, okay? So first, we're going to start with k is 0. Well, k is 0 is going to equal this function. We're going to put a 0 in for the x and add 11. All right, y'all. So K of 0 equals 11, right?
11.
So that was done. So then we're going to go K of negative 17. So same thing, just put a negative 17 in for that X. So let me let y'all answer this one and see how y'all do with these unlike signs. So y'all, negative 17 plus 11.
Positive. Oh, he said, oh, shoot.
-6.
Negative 6. There you go.
Let's see.
So y'all, the trick on these unlike signs, you subtract the bigger number minus the smaller. So 17 minus 11 is 6. But you got to give the answer the sign of the larger number. Okay. Now notice they're keeping you on these negative numbers. So they want to do negative 9. So that'd be negative 9 plus 11. So what is negative 9 plus 11?
18,
3
Positive 2
or 2.
or positive. Okay, yeah. Okay.
Because you can do 11 minus 9 is 2. Larger numbers positive. So the answer stays positive. What do you have next? K of 20. So this is not that bad. That's just what, 20 plus 11. So these are two positive numbers. So since they're both positive, we just add them and keep them positive. So that's what
31.
we're getting 31.
Yes.
All right, now the last one's sort of tricky. I got a K of a B plus 2. So remember, I got to replace the X with a B plus 2. So I'm going to have a B plus 2 plus my 11. Y'all, what in the world can we do to that?
Combine the like terms.
Okay. And y'all, the only like terms we got is these numbers, that 2 and 11, right? So you're going to break that B down. And then let's see, 2 plus 11, that's going to give me what, 13. And that's as far as we can go. We have no more like terms. So good job. That's the main thing in math in this section. If you have like terms, add them together and then be done with it. All righty, I'm going to do this one. F of X equals absolute value of X plus 4.
Can you scoot the paper over?
Oh, which way am I? This way?
The
Or
other way, the other way, the other way.
this way?
Yeah, right there. Thank you.
Okay. Alrighty, on this one, they want me to find F of 2, F of a negative 3, and then F of an A minus 4. Now, this problem I don't care so much for because of this part. Now, I don't mind it on this part, but this one, I'll show you what happens. So F of 2 means we're going to do the absolute value of 2 plus a 4. And y'all, here's the thing. Absolute value in order of operations has the same priority as parentheses. So the first thing you got to do is work those absolute values before you can do any adding, multiplying, subtracting, and all that. So the question is, what's the absolute value of 2?
2.
All righty, so that's going to give me a 2, bring down my plus 4. And y'all, 2 plus 4 gives us 6. So F of 2 equals 6. All righty, keeping y'all online. Let's do f of -3. That's going to be the absolute value of -3 plus a 4. So I got to start with the absolute value. So what is the absolute value of a -3?
3.
Okay, so that's going to give me what? 3 plus 4, which is going to equal a 7. Now, this is the part I don't like on this one is the a minus 4. That's going to be the absolute value. A minus 4 plus 4. And y'all, the reason I don't like this one, we can't do nothing to it. We don't know what sign the A is, so that makes a difference. On this problem, you cannot do nothing to this. So that would be your final answer. They try to make you think you can do -4 and 4. But things outside absolute value cannot add to things inside absolute value. So for the a minus 4 on y'all's, you're not going to be able to do anything to it, okay? And I don't like it when they give us problems we can't do nothing to, but yeah, that's what happened on that one. All right, y'all, let's see what y'all know about these. F of x equals x to the 3rd. They want us to find f of 0, f of -1, f of 5, f of 9, f of a -4, and then f of a -5a. So 1, 2, 3. They hit us with 6 on this one. So let's start out with f of 0. That's going to equal 0 to the 3rd power. Well, y'all, that's just 0 times 0 times 0, which will give me a big 0.
Yeah.
F of -1 will be -1 to the 3rd power. So y'all think about this. A negative times a negative times a negative. When you got 3 negatives, that answer will be negative no matter what. And then 1 times 1 times 1 is 1. So remember this, a negative number to an odd exponent stays negative, okay? All right, so this one's on y'all. F of 5 is going to equal 5 to the 3rd power. Now, do y'all know how to do exponents on your calculator? And I'm going to show y'all, let me share my calculator real quick. I'm going to quit this by hitting second mode. To do exponents on the calculator, over here under the clear button, you see a little upside down V, that's called a caret. So say I'm doing 5 to the 3rd, I would hit my 5, hit the upside down V, and then put in my 3. So now the calculator is going to do 5 times 5 times 5, which gives us 125. So y'all just remember the upside down V under the clear button is for your exponents, okay? All right, so we just said, what did we say? 5 times 5 times 5 was 125. Oh, y'all, and here comes a big one. F of 9. That's going to equal 9 to the 3rd power. So 9 times 9 times 9. And y'all should get a pretty big number on that.
729.
729. Good job. All right, next we had f of what, a -4. So remember, since that's a -4, this answer will be
Negative.
negative no matter what. And then 4 times 4 times 4.
$64.
So we're going to get a -64. Good job. Now, the last one's sort of tricky, y'all. They got us doing an f of a -5a, which will be -5a to the third. So you got to multiply -5a times -5a times -5a. We know that answer will be negative no matter what. Y'all start with the 5. 5 times 5 times 5. So that's going to give me -125. How about the a? What is the a times the a times the a equal?
A cubed.
A cubed. Good job. So notice they're going to try to hit you with a few variables up here like they did with that b plus 2, the a minus 4, the -5a. Sort of just trying to bring you back to some of those rules you might have forgot about, okay? So let me show you what you would do this in the real world. So let me move my paper back up. All righty, y'all. So I'm going to write a formula down and see if y'all remember this. I've got f of c. So they're letting me know c is my variable. That's going to equal 9 divided by 5 times c plus 32. Have y'all ever seen this formula?
Maybe not with the C.
Oh, what you seen it with?
A X.
Okay, but what's this formula for?
Fahrenheit versus Celsius?
Oh, that's it. Perfect. So this will find the Fahrenheit temperature when I know the Celsius temperature. So see, Celsius will be my variable. Once I plug in my Celsius temperature, it gives me the Fahrenheit temperature for it, okay? So what I want to do is I want to find the Fahrenheit temperature that is equivalent to -25 degrees Celsius. So we're starting out with -25 degrees Celsius. We're going to convert that to Fahrenheit. So what we're actually finding is F of a -25. So we're going to take down our 9/5, put in our -25, and then add 32. Now, at this point, you can punch that in the calculator, do your 9/5 times -25 plus 32 and get the answer. But I'm going to show y'all a trick on this. This -25, since it's on top, will divide by that 5. You can divide -25 by 5 and make that a -5.
Okay, can you turn the paper back around so I can screen, so I can write the other part, please?
This way?
No, the other part, the last part. Turn the paper over.
Oh, okay. Let me see.
Yes, sir.
Was it on this one?
If you don't mind. Yes, sir.
Okay. I'm going to have to pull this down a second. All right.
You scoot down just a little.
Pull it down this way.
Yes, yes, sir. Okay.
Oh, okay.
Okay. Okay, hold on, Mama. You think? Okay, you can. Okay, you can go.
Okay.
Thank you.
Okay, no problem. All right, y'all. So I divided that negative 25 by 5, made that a negative 5. So now I'm just going to do 9 times negative 5 is negative 45 plus my 32. So let's see, negative 45 and 32, unlike signs again. So 45 minus 32 gives me 13. The larger number is negative, so that makes that a negative 13. So y'all, that's using a function to convert temperatures, okay?
Could you use the 9, like if it was 81 and like negative 81 instead of negative 25, could you use the 9 and reduce it? Or
No, it has to be a number on the bottom.
okay.
Mhm. Yeah, because that top's always, so what this is like doing 9 times negative 25 and then dividing by that 5. Remember, fractions multiply sort of straight across. Anything below that line is being divided, okay?
Okay, thank you.
All righty, y'all. So then after they let you know about the functions, they just want us to do some more graphing. So I'm just going to pick out a few of these to graph. So like this one wants us to graph f of x. So the difference between this section and the first section, they're using f of x now instead of y. Okay. So they got one like this, -1 plus absolute value of x. And also the difference in this section, they give us a table to use with the x values. So like this one has a -2, -1, 0, 1, and a 2. So they're going to give you the x values. You got to find the y values. Now, if you don't want to sit here and do this by hand every time, we can go to y equals, punch in this, and get all these y values. So y'all watch how quick we can do this. So let me show you on my calculator. So I'm going to go to my y equals, and then let me clear this side out. And I'm going to clear that. So it was -1 plus the absolute value of x. So remember, I'm going to go down here and get my -1 plus absolute value. Remember, to get absolute value, you hit math, arrow right, and highlight the number column. Absolute value is the first thing you got. Hit enter and put in your x. Now remember, I got to fill out a table. So the first thing I would probably hit would be second graph to pull up my table. And they started at -2. So I got -2 showing. So for -2, my y value would be 1. For -1, my y value is 0. For 0, my y value is -1. For 1, my y value is 0. And then for 2, my y value is 1. And you can see how it's sort of symmetric because that 1, 0, remember 0 is the V of it. And then look on oh no, on this one, the V would be -1 because we got that -1 added to it. And then on each side, you got zeros. Each side of that, you got 1s and then 2s. So you can still see it's sort of symmetric. And I'll show you the graph because remember, they make you graph these. And so there's that graph. Remember, the first point you plot on this one has to be the V point, which would be 0, -1. Okay. So you always want to start with the lowest point you got for those y values on these graphs. All right, y'all, question on that?
No, sir.
All right, watch this one. F of x equals x squared minus 2x minus 6. Oh, and over here, remember that was a V-shaped graph. This has got an x squared in it, so it's going to be the parabola. Remember, parabola is a 3-point tool. So they give you a table for this one also. They're giving me -1, 0, 1, 2, and 3. Now, the reason they're giving you the points is they want you to see symmetry on them. Now, on the absolute value, remember, that's the first point to plot was that lowest y value. On this one, the first point to plot will be the 1 because that's going to be the, well, you'll see on my y values, okay? So x squared minus 2x minus 6, I'm going to go to my calculator. Go to my y equals and clear that out. So x squared, I'm going to hit the x and then come over here and hit that x squared button. Minus 2x minus 6. So notice for subtraction, I use those subtraction buttons and not that negative down there. If you use that negative down there, it'll think you're multiplying instead of subtracting, okay? So there's my x squared minus 2x minus 6. I'm going to go to the table by hitting second graph. So the first point they gave me was -1. So notice at -1, I get a -3. At 0, I got a -6. At 1, I got a -7. At 2, I got a -6. So now you're starting to see the -6 repeat. So my last number should be, what, at 3 is a -3. And then y'all, let me show you the graph. So there's our parabola. So notice that lowest point will be the point we had, what was 1, -7, if you're going to graph that on MATLAB, okay? Remember, you got to start with that, start with this point here. I don't think it makes a big difference in this section on the parabolas, but I'm getting y'all used to this because later in life, you do have to start with them low points on those, okay?
Could you explain the where you start again? Like is it the third down? Like the third number down on the first plot, or?
So the reason I use this up here for my first point, because this was my lowest y value. And the lowest y value is always going to give you that little vertex point on that one. And then the same thing on this one. The reason this is the first point, it's not as picky on this one. Let's go do one of these real quick. So this was what, let me go find this on the MATLAB real quick. I'm going to have to do this is 2.2. And that would be number 12. All right, so let me pull it up and then I'll share my screen. All right, so they changed it up a little bit. X squared minus 2x minus 1. So we're going to go graph this real quick on calculator and see what these x values are, okay? So let me get my values. So I got -1, 0, 1, 2. So it looks like the same numbers they gave me on my other one. It's going to be a little different because they got a different n number. So let's go to y equals, and it's instead of a -6 at the end, they got what, a -1 on this one, right? All right, so I'm gonna go to the table, second graph. So let's see, at -1, we got a 2, then we got a -1, -2, -1, 2. So they should be symmetric. And then look what it's doing. My graph is pretty much the same, other than the last one had that -6. So go to Math Lab. So the first thing we would do is come in and put these numbers. So I had a 2. For 0, we had a -1. We had a -2. A -1. And then a 2. So once you put in them numbers, it's going to say good job. And then we're going to click to enlarge our graph. So remember, this is a 3-point quadratic tool. So click on it. So I'm just going to go out of order and see if it makes a difference on this one. So I'm going to do -1, 2. So go to -1 up 2. Click that. I'm going to go to 0, -1. Click that. And then I'm going to go to 1, -2. And click that. So I don't think it's making a difference on these, what order you go in on the parabolas at this point, okay? And then you would check your answer and be done. So did that help on that one?
Yes.
Okay. So the one that definitely makes a difference is, at this point, is only the absolute value. This parabola, they're being nice at this point.
So you just start with the lowest y value?
Yeah, you can.
Okay.
Yeah, it'll work on either one. Now remember, if this was flipped upside down, I would start with the highest y value. All righty, let's see. How about this one? Let me do one more of these and then we'll look at something different. I got a x3 plus 8. And let's see, they're giving us some values to use on this. They're giving me -2, -1, 0, 1, and 2. They'll probably keep this number small on a cube because remember those 9s and stuff got really big. So let's go to calculator, get some points, and then I'll show you how to graph this one. All right, so go to y equals. I'm gonna clear this out. We had an x cubed plus 8. So I'm gonna do the x, hit the upside down v, cube that. Now notice you got to arrow down so it won't keep it up there with that exponent. So I'm going to arrow right, bring my thing down and put a plus 8. So make sure you arrow it down after you put in your exponent, okay? So let's look at the table, second graph. So they gave me -2. I have a 0, then a 7, then an 8, then a 9. And when it was 2, I got a 16. So I got my table. So we need to go put them values in before it'll let us do the graphing part. Oh, and it switched it on me. I knew it would. All righty. So I added 8. So let me take 6 away from all these. So that should be what, a negative? X cubed, that'd be -8 plus 2 be -6. -1 cubed is -1 plus 2, which is 1. 0 cubed is 0 plus 2 is 2. 1 cubed is 1 plus 2 is 3. 2 cubed is 8 plus 2 is 10. So y'all, let's put them numbers in. Now, I'm going to click to enlarge graph. Notice the second row, the second tool says 4-point cubic tool. That's what we got to use on this one because it's a cube. So you click it. And y'all, what's nice about this one, it don't matter what order you put it in. So I'm going to do, say, -2, -6. I had -1, 1. I had 0, 2. And then I had 1, 3. Notice when you put that third point in, it puts in the curved line for you, and then you save it and be done. The order does not matter on that one. And then, I didn't show you what it looked like on the graph, so let me go back to my graph and actually graph it. And see, it makes them little curvy uphill lines, okay? All right, so on these cubics, you're going to use the 4-point cubic tool. All right, y'all, one more quick thing and then we're done. This is how to determine if a graph is a function. So how to determine if a graph is a function. So we're talking about looking at a graph. How can I look at a graph and tell if it's a function? We use what we call the vertical line test. Vertical line says if a vertical line can intersect a graph more than once, if a vertical line can intersect a graph more than once, the graph is not a function. Because remember, if a vertical line intersects the graph more than once, that means your X value had a choice. And we said a while ago that X's cannot have a choice. So I'm going to pull up some graphs and we're going to see whether these are functions or not. So let me see. I need to move down to number 15, it looks like. All right, y'all see a graph on your screen? Looks like a V.
Yes.
So the question is, if you drew vertical lines, so let me go back and show you what I'm talking about on that. So let me draw this graph real quick. So that graph, here's my X and Y. So I'm just going to make one over here sort of similar to it. So there's my V-shaped graph. So the question is, will a vertical line intersect this graph more than once? Well, let's see. Here's a vertical line I just shot through it. Intersects it one time. Here's a vertical line. Intersects it one time. There's a vertical line. Intersects it only one time. Do you notice anywhere that I draw a vertical line, it's only going to intersect that graph at one point. So since these vertical lines do not intersect it more than once, this one would be a function. Now I'm going to show you one real quick. So here's an X and a Y. Let me pull that down for you. So what if I had a sideways looking parabola? So y'all, let's draw vertical lines. Here's a vertical line. Uh-oh. That vertical line intersected at that top and at the bottom. And notice, I can do that in more places than one. These vertical lines are intersecting at more than one time on the graph. So this one would be a no. Okay, so we're just looking at what will a vertical line do to my graph? Intersects it only once everywhere? It's a yes. If it intersects it more than once anywhere on it, then it is a no. So y'all, let me take y'all back and see what y'all think. So is that graph a function?
Yes.
All right, so we're going to click yes. Check that and move on. All right, let me make this one larger. Is that graph of a circle a function?
No.
No, because if you drew vertical lines, it's going to intersect that thing at least twice everywhere. So you say no. We check that and move on. Is this the graph of a function? So let me make this a little larger.
No.
Nope, same thing. If you drew vertical lines, it's going to intersect the top and the bottom. So good job. That's a no. So the zigzag line, is that a function?
Yes.
Oh, good job. Because everywhere you go, those vertical lines are only going to intersect at one place. So you'd put yes and be done. So y'all, that's mainly everything from 2-1 and 2-2. Now you'll have support lessons. Now the support lessons sort of go over a few of the things that they think you should know for college algebra, like drawing straight lines and stuff. And what I do on those. So if you have any issues with your support tonight, tomorrow after class, during the support lab, we'll work on that and get y'all good. Okay. All right, so y'all have any questions over this 2-1 and 2-2? It's basically just trying to get you back in the groove of doing the graphing and stuff and sort of showing you what a function is, okay? Now, we won't have a support lab today because we ain't had any homework yet. So tomorrow I'll start doing my support labs, and what I'll use that for is going over any homework that y'all have any issues with. Okay, so if you get down there tonight and you got issues and you can't figure out the homework, email me, and if you can't figure it out then, we're going to use that lab to fix y'all's homework, okay?
So we can start the homework tonight for 2.1 and 2.2.
Yes, ma'am.
Okay.
And then and y'all remember, y'all have only got 5 weeks in here. So y'all don't want to get behind on homework, just sort of keep up with it. If you get stuck, don't sit and stay stuck on a problem. Move on and skip it and do something else that you know. And then we can always come back and fix what you didn't know in that lab, okay? All right, what else questions y'all got?
Well, it was nice meeting you.
Nice meeting y'all. Now remember, I've got all these videos in Blackboard under those lecture videos. I got videos on showing you how to use the calculator. I got videos on you showing you how to work the math lab and graph those graphs, okay? Any issues, email me and I'll try to get back with you. and get y'all fixed. All right, so I'm gonna stop this recording.